Hello, this is John Amabile, and welcome to my Chapter 4 video where I'll discuss space infrastructure, how we'll build it, what it will be used for, and how it will be paid for. So kind of the biggest idea for this chapter is that all of this stuff exists and is in orbit right now. So there's no launch costs, there's no development costs, there's none of that stuff. We have an enormous junkyard outside of the Earth. My plan is simply using that to make trillions of dollars. So the biggest pieces that I'll be discussing, there are 5 Stage 3 Saturn V fuel tanks in Earth orbit right now, left over from the Apollo launches. Well, there's 4 that we know about, and the 5th we strongly suspect. Each of these are enormous. If you've ever been to any of the space centers, they have a few of these sections on display. The Skylab space station was made from one of these things. One of them is about the size of a 4-bedroom house, and there's 5 of them in Earth orbit or in heliocentric orbit around the same area as the Earth. So it would be relatively simple to send a nuclear thermal rocket-powered vehicle out into space to grab these objects, place them in a stable, controllable high Earth orbit. Then we can grab other random pieces of space debris. I give a specific list in my book, of which there's something like 80,000 kilograms. Since we launched all of these things, we know mass, shape, size. They're all made of very expensive space, like aluminum, titanium, silicon for solar cells. A lot of them have intact solar cells on them right now. It's just a wonderful treasure trove of stuff. Also, the International Space Station is scheduled to come offline in the next few years. It was not put in a stable orbit. We have to spend a lot of money every year to push it back up. So anyway, as part of my plan, I propose that we buy the ISS, or rather, the ISS should be exchanged to Space Corporation in exchange for stock. So that gives us even more workspace and solar cells as well. So anyway, now that we've accumulated all of this junk in Earth orbit, which we will launch 4 small space vehicles called Proto-Ballista, which will just kind of be like a utility robot that you would see in a science fiction movie. Very simple, small machine that just kind of collects this debris into orbital scrap heaps, of which we'll have, by my plan, we'll have 4 proto-ballista, and so we'll probably have 4 orbital scrap yards, eventually coalescing them into one large one. Well, anyway, so all this debris, this will allow us to make a propellant station and a green station. So a green station, it's basically a farm. We'll put several of the Apollo fuel tanks together, we'll put hydroponics on the inside of them, a few cosmetic alterations, which I discuss in my book. But we already have these 5 massive self-contained, objects in space. We just need to add lights, connect them, and start growing plants in them. Of course, another part of this, which I kind of get more into in Chapter 5, is we're going to bring back a small ice asteroid to Earth orbit. So once we have the ice, we can put that inside of the green station. We can just melt it with a little bit of energy, and then, poof, we have food. So we'll use this to grow food for all the manned missions going out from the Earth. Also, of course, oxygen. The astronauts themselves can exchange the CO2 they breathe with the plants, so it'll be a supply depot for us, and it will stay in high Earth orbit where it needs much less maintenance. Also, propellant. Both the International Space Station or the other various pieces of space debris we can use to collect solar energy, which we can then convert through electrolysis into propellant. You take water, you run electrons through it, it splits into hydrogen, which is what the nuclear thermal rockets use, and oxygen, which is what we breathe. Also, the nuclear smelter that we're going to launch, which we'll be using that's how we're going to be melting and rearranging the debris. We can also just put water in there, thermalize it, or electrolyze it with a few. We'll have to add some kind of a steam system if we wanted to electrolyze it, but that won't be complex. And then we can get as much propellant as we like from our nuclear smelter. But the solar stuff in orbit, to include the ISS, after we buy it and rename it, that stuff will be a slower yet free source of propellant. And since we're in an area with no atmosphere, no gravity, it's not like on Earth where you need a huge amount of propellant to move a 100,000-ton ship through 6,000 miles of ocean that has the density of concrete. We're moving objects through nothing and with no gravity, so very little fuel will be able to get us quite far. All of these objects would be contributed from the states that own them. My plan, as I've mentioned a few times, is based on U.S. government-owned technology. So we own pretty much all the stuff in my plan. And if it's something we don't own, of course, we would exchange stock shares. If it was owned by ESA or the Russians or whoever, we would offer them stock shares in exchange for the debris. And if they didn't want that, then that's fine. Capitalism is all consensual. If they just want to have paint chips floating at 60,000 miles an hour through space, waiting to strike something where they can be sued for it under existing laws, they are free to do that. If they want to give up both the legal liability and just the day-to-day tracking headache for that stuff in exchange for something that has real tangible value, then, that would be a good decision for them to make. In other case, in later chapters, I'll kind of go into what we will use this fuel and food for, but this will shift the logistics of space. So instead of us having to carry oxygen, food, fuel, even a lot of spare parts, hull shielding for radiation, once we collect a lot of this stuff, we can start building machines out of it. I mean, 80,000 kilograms, it's like the size of a small boat floating in Earth orbit. And we can just build all kinds of stuff. It would be simple components, not the complex things we made on Earth, but this would drastically reduce cost by having these things already at the top of the gravity well. And finally, our expertise with our smelter and cutting up satellites and debris, this will transition very easily into recovering small asteroids and cutting them up with our smelter and mining them and getting all the processes to work, the proto-ballistas, the katas, synchronizing all of these things, training our personnel, and then working on the software and the hardware of all of our equipment. So the debris utilizations in Earth orbit will transition easily into small asteroid utilizations in or near Earth orbit. Well, anyway, thank you for your time. I'll be making my Chapter 5 video soon, and I hope you all are having a good night. Take care. Bye.